in which we will also discuss representation using linear equations and linear equations with n variables. Second topic is graphical characteristics, in which we will discuss graphing two variable equations, intercepts, the equation x is equal to k, the equation y is equal to k, slope, and the third topic is slope-intercept form. We start from the characteristics of linear equations. Standard form of linear equation with two variables is ax plus by is equal to c, where a, b and c are constants, x and y are variables. Also a and b cannot be equal to 0. Linear equation is an equation between two variables that gives a straight line when plotted on a graph. Linear equations are first degree equations, that is, power of the variables involved is exactly 1. Examples. Some examples of linear equations are given by number 1, y is equal to 2x plus 1. Number 2, 5x plus 3y is equal to 6. Number 3, y over 2 plus x is equal to 3. Representation using linear equations. Solution set for the linear equation ax plus by is equal to c is the set of all ordered pairs x, y which satisfy the given equation. And in the set notation we write S is equal to xy such that ax plus by is equal to c. Now we consider an example. Example number 1. Solve the linear equation y is equal to 2x plus 1. First of all, we take some values of x and fix the corresponding values of y with the help of given linear equation. We construct the following table. In the first column, you will see the values of x. In the second column, values of y, which is given in the form of y is equal to 2x plus 1. And in the third column, we represent x, y, the points. For example, if you take x is equal to minus 1, then y is also equal to minus 1. So we get the point minus 1, minus 1. Secondly, if you take x is equal to 0, you get y is equal to 1. So the point will be 0, 1. Similarly, we get two more points that are 1, 3 and 2, 5. Now we represent these points on the graph paper. On the x-axis, we take the values of x, and on the y-axis, we take the values of y. So when we join these points, we get the following straight line, which is called y is equal to 2x plus 1 line. Dear students, now we represent another example of linear equations. Example number 1. A company has fixed costs of $7,000 for the plant and the equipment and variable costs $600 for each unit of output. What is the total cost at varying level of output? Solution. Let us denote by x the units of output, and again we denote c by the total cost. Then total cost is equal to fixed cost plus variable cost. That is, c is equal to 7,000 plus 600 times x. So cost at varying level of output is represented in the following table. First column is output, which is equal to x. Second column is total cost, which is equal to c. And the third column is the numbers x, c. So if you take 15 units, total cost is 16,000 and it is represented by the number 15, 16,000. Similarly, if the output is 30 units, then the total cost is 25,000 and the number is represented by 30, 25,000. Now we represent our data on the graph paper. On the x-axis, we take the number of units, and on the y-axis, we take the amount, that which is in dollars. So if we take the point x is equal to 15, similarly, we take the second point x is equal to 30, Then we take the corresponding values of y. Now we join them and we get the following straight line. Now we discuss linear equations with n variables. A linear equation which has n number of variables is called linear equation with n variables. In linear equation with n variables, each variable has power 1. So the general form of linear equation is given below: a1x1 plus a2x2 plus a3x3 plus so on up till an xn is equal to b, where x1, x2 up till xn are variables and a1, a2 up till an and b are constants. Also, a1, a2 up till an cannot be equal to 0, but the constant b can be equal to 0. Now we see the graphing two variable equations. Graph of linear equation involving two variables is a straight line. To sketch a graph of linear equations, we have to consider the following steps. Number 1, identify and plot the coordinates of any 2 points which lie on the line. Number 2, connect the 2 points with a straight line. Number 3, extend the straight line in both directions as far as necessary. Dear students, now we see an example. Sketch the graph of the equation 2x minus 3y is equal to minus 12. First of all, we take some values of x and find the corresponding values of y with the help of given linear equation. That is, we construct the following table. On the first column, we represent x. On the second column, we represent y is equal to 2x plus 1. And in the third column, we represent the points x, y. So if we take the values of x from 0 to 6, we get the corresponding values of y, and then we represent it on the points in the third column. Graphing two variable equations. Now we give the graphical representation of our given linear equation, and it is shown in this table. On the x-axis, we have taken the values of x. Similarly, on the vertical axis, we have taken the values of y. And the graph shown is a straight line. Dear students, now we define intercepts. Intercepts are the points where a graph crosses the x-axis and y-axis. The first one is x-intercept. The x-coordinates of the points where a graph intersects the x-axis are called the x-intercepts of the graph and are obtained by setting y is equal to 0 in the equation of the graph. Y-intercept. The y-coordinates of the points where a graph intersects the y-axis are called y-intercepts of the graph and are obtained by setting x is equal to 0 in the equation of the graph. Intercepts. Take the general form of linear equation of two variables, which is given in this form: ax plus by is equal to c. If we take b is equal to 0, then we have ax is equal to c. Dividing both sides by a equation, ax is equal to c will become x is equal to c over a. Since c and a are constants, so we can take c over a equal to k, which is also another constant. So that is, we get x is equal to k. Dear students, now represent the graph of equation x is equal to k, which is a vertical line crossing the x-axis at the point x is equal to k. For these equations, there is x-intercept k, 0, but no y-intercept, because this line is not crossing y-axis unless k is equal to 0. For example, if you take x is equal to 3, you will see the following lines in the graph. Dear students, again we consider the general form of linear equation of two variables. That is, ax plus by is equal to c. If we take a is equal to 0, then we have by is equal to c. Dividing both sides by b, the equation by is equal to c will become y is equal to c over b. Since c and b are constants, so we take c over b equal to constant k, so which is another constant. So we have y is equal to k. Now we represent the graph of the equation y is equal to k which is horizontal line crossing the y-axis at the point y is equal to k. Equation of this form has no x-intercept unless k is equal to 0. That is, this line does not cross x-axis. For example, if we take y is equal to 3, then we get the following horizontal line which is shown in the graph. Dear students, now we define slope. The inclination of a line, whether it rises or falls as we move from left to right along the axis, and the rate at which the line rises or falls. The slope of a line may be positive, negative, 0 or undefined. A line with positive slope rises from left to right. A line with negative slope falls from left to right. Horizontal line has 0 slope. Vertical slope is undefined. That is, vertical slope is infinity. Dear students, these 4 types of slopes are represented in the following tables. The first table shows you the positive slope. The second shows the negative slope. The third one shows the 0 slope, or which we call no slope. The fourth shows the undefined slope. Dear students, now we give you the formal definition of slope. Generally, slope can be represented as slope is equal to delta y divided by delta x, where delta y denotes the change in y and delta x shows the change in x. It is represented in the following diagram. On the x-axis, we have change in x, that is x2 minus x1. Similarly, the change in y-axis is y2 minus y1. So, if we join these points x1, y1 and x2, y2, so the division of delta y by delta x will give us the slope. 2-point formula. We can determine slope by using 2-point formula. The slope m of a straight line connecting 2 points x1, y1 and x2, y2 is given by the following formula. M is equal to delta y divided by delta x. That is, m is equal to y2 minus y1 over x2 minus x1. And keep in mind that x2 and x1 cannot be equal. Dear students, now we give you the example of 2-point formula. Find the slope of the line segment connecting the points 1, 1 and 2, 4. We will find slope using 2-point formula. That is, m is equal to y2 minus y1 over x2 minus x1. Now we substitute the values. We have x1 is equal to 1, x2 is equal to 2, y1 is equal to 1 and y2 is equal to 4. So when we substitute all these 4 values, we get m is equal to 4 minus 1 over 2 minus 1. That is, m is equal to 3 over 1, that is m is equal to 3. So slope of the line segment joining the points 1, 1 and 2, 4 is 3. Dear students, now we give the graphical representation of the line segment passing through the points 1, 1 and 2, 4. And it is given below in this diagram. From here you can see that the slope is positive. So the line segment rises from left to right. Dear students, now we give you another form of the equation. That is, equation of any straight line is called linear equation, which can be written as y is equal to mx plus c, where m is the slope of the line and b is the y-intercept of the line. For example, if we write y is equal to 2x plus 3, then y-intercept is 3 and the slope of the given equation is m is equal to 2. Dear students, now we give you an example. A manufacturer's total cost consists of a fixed overheads of $200 plus production cost of $50 per unit. The question is, express the total as a function of the number of units produced. Number 2, graph the equation. And number 3, identify the slope and the c-intercepts. Let x is equal to the number of units produced Let C of x is the corresponding total cost. Then total cost is equal to cost per unit multiplied by number of units plus overhead cost, where cost per unit is 50, number of units is x, overheads are 200. Therefore, the equation will take the form C of x is equal to 50x plus 200. Therefore, the cost function will be given by C of x is equal to 50x plus 200, where C intercept is 200 and slope is 50. Graphical representation of the given problem is given in the following diagram. On the x-axis, we have taken number of units. On the y-axis, we have taken the cost. So from the graph, you can see